This is the capture is the full screen. No, that would be fine, I think. It will come up whatever I will choose. Yeah, it is audible, it seems. Uh-huh. The video capture is this one then. Yeah. Which one? This one. This is camera one. This was the capture actually. It is image capture, so it seems to be this one cameraman. Just a second. This is the broadcast. Now there is a capture button, he said. Okay, maybe for safe side I will start the Snagit also. Padma, is it coming there? Uh, okay. Sorry for the delay, will start now. Okay, hello everyone. So today we'll start with the seminar that is on the introduction to cloud computing, and there are a lot of different cloud providers. So I'll be giving the demos on Amazon Web Services for that. So this is about me. I have mostly worked on Microsoft technologies, and this is the information to connect my profiles. So the agenda for today's session will be, first we will go through a brief on the history of how cloud computing actually came from the initial PC era, then to the problems that cloud actually can address, which we are facing in if we manage or we go for our own servers. Then there is a some we'll discuss on the distributed programming, because I think it is more related to the distributed programming actually, if you think in terms of programming for cloud related apps. So we'll go through that. Then there are some cloud providers that we'll discuss what are the types of cloud providers. Then we'll start with the Imagine, with the introduction to Imagine services, and then we will see what are the accounts facility available in Imagine to create and use it. Then what are the different services on Imagine, And the seminar will be mostly on the Windows EC2 instance and S3 server that we'll be seeing. And this is all on web only, so we'll be seeing all them in browser level. So there are some previously, means before going to the demos, I'll go through some basics on the cloud. So this is what actually I've created in terms of a layout and a evolution of computing with time. So the first one you can see is the mainframe and terminals. So the idea is like previously when the initial days, 1970 or something, that mainframe was the computer that people uses, and it was like they were not able to see one people per one computer. It was very costly, and for any research work or education purpose also they used to use one mainframe and multiple user use it. So it was a many to one relationship in terms of user to computer. Then came the era of PC, personal computer. So each user has got its own computer, so he can research whatever he can. Then we came in the web, we connected all the PCs and we come up like we are connected to each other. Then we, with time, we saw the need of servers where multiple PCs will be merged together, and we created servers and use the computing power there. And finally, that is the cloud, we say is data center. We have combined all the servers because we needed more power than that and created our own data centers. So even two servers can be called a data center as long as they are more than a server. So this is the definition. There are lots of definitions. So I just picked this and wrote it like this: that cloud computing is nothing but simply the ability to use network of remote servers to store, manage, and process data. So it's like you can store bulk amount of data. That could be a cloud service. It's not only about computing, it's about storage also, managing and processing the data. Then the computing problems that cloud can solve. Actually, this is where actually we will be thinking either we need the cloud or not, like the scalability. Let's say the example of scalability could be, all of a sudden you have designed a gaming software and you're not sure how much hit it will be going to get, and all of a sudden you saw it's a hit and everybody started liking it, and all of a sudden you need more servers. But if you're managing the same thing your own, you won't be able to get that. All of a sudden you need to purchase servers, you have to manage them and start deploying things. But cloud gives you the scalability feature that with time, whatever the load comes in, you can scale your application or the servers as long. And the predictable bursting is like, this is the predictable bursting is actually the idea behind how cloud came actually. Like initially how Imagine came. Imagine is the first cloud provider. In 2002 they started. The idea was, Imagine was like in US, it is a service which provides here also, it provides goods for us, we can purchase there. So in US what happens is, previously they were having all this seasonal hits. So in Christmas time they will have a lot of hits, people will purchase. So the server will be more loaded on in terms of Christmas season only. So some guys from Amazon said, and the computing power is huge. To maintain even hundreds of servers itself, you need to have a place like that. You need to build the infrastructure. You have to manage them, and you have to keep them for the next Christmas also. So that computing power they wanted to use somehow, and the idea came up with, let's give it on rent. Some people, they started renting their server. So some people used it, and then when Christmas came, they just pushed all the small servers to one and they used it. Again, the same thing happened. And from then, one by 1 year, they came up with all these services. So that is a predictable bursting, that you can see that there is a seasonal load I will get. The unpredictable bursting could be like, all of a sudden some storm came. So news channels can take advantage of it. They have no idea whether I will get a load, but all of a sudden if load is coming, they can scale it, their application. Then the load balance is also related to that also. Then big job testing, like the research work, scientific research or medical testing, they can do. In cloud it will be better because you cannot manage that level of server of your own. Because there are some problems that we'll see. These are like, what if I want to manage my own data center? I will create my own data center and I will start using them. So the problems are, these are the few problems. Electricity, you have to get an 24/7 electricity power problem, then the infrastructure creation cost itself, it will be very huge if you are creating of your own data center, because you don't know how much you will know get it, then the problem with the load and all, then you're off focus from your actual work. Like your domain could be like automobile industry or a banking, maybe you are a banking provider, but you have to give a lot of focus on data center creation, how to manage servers, how to put all those security patches, then the you have to secure your things from hackers. So for this you need skilled people. So it itself is another big area of work than your own domain. So you can think of choosing cloud for this. Then load balancing is always a problem if you maintain of your own. So the solution is of course outsource, which these cloud providers give us. And there are a couple of problems with cloud that we need to consider if we are planning to migrate our application or website to the cloud. So it's like, what if server dies? What if the data center itself got crashed, or fire happened there, something? So the solution to this is it can happen to your servers also. So there should be a backup plan always. It's not like it can happen to data center, it can happen to us, but more likely it can happen to us only. In data center, it is more secured. Then the sensitivity of data. If we are a banking application or something, these are always a concern with cloud. A lot of people don't feel comfortable going for cloud for these area, like if you have a sensitive information, something. So it's like recently some bank from German, they got into this Amazon also in their banking application, but they get into cloud. So they're working fine. Then there are some legal issues. So the major legal issue is the countrywide problems. Like there are different countries, you deploy your data in one country, you cannot access this from another country. Plus the migration, you cannot migrate your data from one data center to another data center in two different countries. There are few legal issues of this sort. So if you are going to need such compatibility also, where you need to migrate your data frequently, then you need to think of that. Okay, then this is the cloud service model. The first one you can take as a private computing that we all use. Like Mindfare is hosting his own server, static server, and managing everything. The layers are like from networking, storage to the data application, the patches, everything is managed by the person who is managing the server. So that is private cloud. Then there are three types of, you can say, the major cloud computing, that is infrastructure as a service, platform as a service, and software as a service. So the first one, infrastructure as a service, we can think of as like the PC we are using actually. The what they will be providing, the cloud person, he will give us the PC on terms of that we will be seeing in the demo today, that we will create an EC2 instance, a server, and at runtime we will be generating our own instances with whatever package we need, like the memory power, the network usage, everything we will be specifying them. They will give us the server of that capacity, but the rest of the thing, that is the OS, from the OS layer to the application layer, we have to manage. That you means the person who is actually going for this cloud service. So for infrastructure as a service, we need to manage these things. But in platform as a service, most of the thing has been managed by the provider itself. And you just need to worry about your own application and your own data. So you deploy your application and your data, how you manage, or where you want to store, and your application will run fine. The security patches, the system updates, everything will be taken care by the provider itself. Then comes the software as a service. Here everything will be managed from the vendor perspective. The examples are like the Gmail, all Google applications that we use, that is nothing but a software as a service. You get everything from cloud. The benefit in software as a service is you don't have to install, like the Gmail, you don't have to install the mail client, you don't have to install anything related to that. You just open it on browser and you can use it. And there are lots of benefits in software as a service, like the problem with all this blockage, and it is more free in terms of if you go as software service instead of creating of your own and deploying that application across all system. The package updates also, all user have to update at once. These are the problems So software as a service can solve them, but there are some problems of software as a service also. Like if you want to customize your application, if I want to customize my Gmail application, I cannot go beyond what they provide. I have to go for that. And platform as a service, the Windows Azure is a example of that. Platform as a service. In infrastructure as a service, Azure gives some part of it, then Imagine gives heavily on that. You can get the instances, you can get the storage services of its own, S3 service that we call. These are all infrastructure as service. Okay, anything on these three layers? Actually, this is nothing but an layer on layer. Infrastructure is the core layer that we get a PC with nothing. We will manage everything with our package, update everything. We give another layer of abstraction on this. Yes, OS will be installed by them, but all the update work you have to do. You will choose the OS. Yes. Plus the OS capacity, means the ability to choose the OS is also up to you. You can choose your own Linux or Windows Server, whatever. No, platform actually it gives you as a platform. Like you're going for platform as a service, Windows Azure, it will give you a Windows system with all those information. In platform as service, all you need to worry about your application and your data. Okay, then what programming change? This is actually when I started working on Amazon, this is the first thing I was worried about. What programming change I need to do? My application will go to cloud, so I can directly go and paste it on cloud and host it. That is possible if you go for that infrastructure as service. Obviously, you have a system, here. You just need to deploy it there, and you are using cloud service. So that is a way, but there are some programming changes you need to do if you're going for cloud services. So why so? The analogy idea would be like the electricity. We have our own grid, let's say. Right now I have created my own grid power plant, and I want to build power this whole building. So obviously the switches will not be the same that we are using. We will get their own specified switches which will take input of maybe 1000 volt or something, and it will run fine. So all of a sudden we thought of getting for a outsourced grid like Gridco or something, who will give me the power and I will use it. So there at that time we need to change our own appliances according to the voltage or whatever specification they are providing. So that is the change we need to do in terms of electricity is concerned. So the thing is same in local versus cloud. Locally our application is working fine. The same thing will work fine in the cloud also. The changes will be the way we are communicating with files with the cloud, the way we are saving the cloud. Like in S3 server, there are requests we have to make to save. The folder structure will not be same in everywhere. Like in Windows, you can create a folder, then go inside and files everything. Maybe in S3 there is a bit of change in that. So that is those changes we need to do in terms of programming aspect. Then the machine level changes. This is the same as we were discussing, like the adding and removing a virtual layer. This is like the distributed programming, like what example is you are hitting the server. Since it is a cloud server, maybe 2-3 servers are there. You are requesting a server for one particular page. You got the page. What as a developer we think is it's a object only. We are creating an object out of it and using it, and in the next call we are expecting it to go into the same server and use the same object. So our application is designed like this right now. Whatever we use in, which is not on cloud right now, so it works fine. But in cloud, when it gets into multiple computers, definitely the same object will not be there in every places. So your application has to take care whether it will not need the same object, the same references each time it will make a call. The application should be independent of that. And the machine changes would be like, today the machine is there with some specified set of tools, and all of a sudden this machine got down. So some technical person in that data center changed the machine. Maybe the configuration would be same, something will change. So your code should be machine independent, because you are not managing, you are not sure even the changed machine will be supported with that or not. So that is one thing. Statelessness is the same load balancing that object has to be the same, otherwise the load balancing can't happen. We were planning for this load balancing to apply on our website, but there were problems because the site was using session variable. So it is a local object. Each time you need to refer it, and also you cannot apply. Yeah, yes, you can store. That is a programming change, right? So that programming change, if you do, you're fine with the load balancing. But in our application, it wasn't there. So obviously, we couldn't take advantage of that. Okay. So this was all about the theoretical aspect of it, and we'll go to the practicals. So this console.imagine aws.imagine.com is the web service URL where you can see all the Imagine web services. So these are all services related to the compute and networking. These services comes in for storage and content delivery. These services are there for database and for deployment, analytics, app services. So these are just you know divided into the role of uses. So today we will be discussing on EC2 from the computing related area and S3 from the storage, and these two are the major hit from Imagine. Actually everyone uses this. So how this uses, you need to just, it is very UI intuitive. There is nothing very hi-fi coding for this. You just need to create your instances and follow the instructions properly. So you can see the my running instances is one running instances that I've created, and which is using one elastic IP. This IP is used inside the Imagine to connect to each other's computer. This is not exactly the static IP. So this launch instance area is there where we can start launching an instance. So here are the places we can see, means managing the EC2 dashboard. There are events you can specify, the instances you can see, AMIs. AMIs is nothing but Amazon machine images. So Amazon has created its own set of images, like 2008 server R2 plus 600 MB of RAM plus this package. So this is one AMI, Amazon machine image. And another came like 2012 R2 data center plus 16 GB of RAM. This is another machine images. So we will choose one of the AMIs from here. So let's launch an instance here. So the first thing you need to do here is choosing your AMI. Okay, before we go into this, since I've logged in here, actually I missed to tell you the account creation for Amazon. So here Amazon, obviously you can pay as per their pricing and you can get your accounts for the uses. But if you're starting and learning it, so you can always start as a free user. So there are people, means it is a quite your own choice, because Amazon doesn't provide you tight restriction. Like if I'm even $1 I'm exceeding, disable my account or something. It is not there. All you need to do is use all the services that is available in free tier and use it up to the level it is provided. Like the free usage tier, you will, it is given like the EC2 instance, you can create 750 hours of EC2 instance for 1 month, and the Amazon gives you 12 months of free account. So as long as you are using 750 hours in 1 month, so you create 2 EC2 instance and use, you know, 3, how much, 375 or something. So if you use that much, so it is fine till that point of time. And you have to enter your sign up for the Imagine account. Like this is for the EC2 750 hours of Windows Linux micro instance. You cannot get the major instances obviously, so they will give you the micro instances which have very limited capability to do anything. Then the S3 storage, you will get 5 GB of storage, and these are monthly repeated. You will get everything per month. Then 750 hours of micro DB instance if you use, and there are every features available in free tier with their limits. So you can create an account. So since I have created, I will skip that part. This is all about the introduction, how to create an account. Okay, so here in choosing an Amazon machine image, so these are the set of machine images that is available to me, and you see there is a free tier eligible is added here. So you can see Amazon Linux, this one I can go for a free tier, so I won't be charged. So I will go for a Windows instance here. This is a Windows 2012 standard edition, 64-bit. So we can go for this one. Okay, here also that is a machine image we created. Now we have to change the which kind of micro instance we need, instance type that we call micro instance or medium, large, whatever. But my since this one micro instance is in free tier, I'll go for that one. You can see the differences, you know, memories. You can go for any number of memories, 60 GB of memory with large one with 108 CPU, this one. Okay, so let's review and launch. We'll review our instance, whatever we need. So the okay, so this is a T1 micro instance with one CPU and 613 MB of RAM, and this is a very low capacity one. So you can review everything out here, whatever you need. Edit, you can edit your image, you can go anything. So I will just start launch. Okay, this is an important part in creating an EC2 instance. I had created an EC2 instance and I had created an existing key pair. Is I have one key pair of it. So when you are creating your own first whatever Imagine machine image or a new instance, it's an existing or it's a new one, you need to either create your own, create a new key pair you can go for, or choose an existing pair. If you create a new pair, it will give you another key pair. You need to download it right now. Let's say I will give a name and I will download it. I will get an email. But if I haven't, sorry, this is like password, you know, the public password and the private password. Amazon keeps a public password for its own uses, so he will ask you, and when you give your private password that we will be getting right now, the PEM file, public key file, that you need to provide, that will be decrypted again, and you will be getting the password here. But this is an important area because this is the only chance you will get to connect your EC2 instance. If you lose the password here, you won't be able to retrieve it anywhere. So I will choose an existing pair that I have saved with key pair name. So this will launch your instance. It will take a couple of minutes to create the instance on cloud for your uses. You can see again all those instances in EC2. Two running instances it's now. So you can see those instances here. Okay, so this one I have been running. So this is fine. This has been initializing the status and creating the new instance for us. Once the status is fine, we can start on this one. So till this point, if anything you need to ask. Basically for learning purpose, we can choose whatever free tier eligibility are there, and these are pretty fine. I have used this particular instance I'm using for hosting my own site, and it's working fine. As long as you're not reaching that load limit, you should be working on a free tier only. And yes, on the same note, some people may think, you know, what if I'm increasing my limit and I don't have any track of it? So there are some alarm setting. You can go here and create your instance alarm or the whole Imagine site alarm. Like even if I'm just increasing from $0, if I'm moving out, then give me an email or whatever way of connection you will want to give. So it will send you an email on that. It will take a couple of minutes to get the server ready. I think it would be better let we can leave it here to be launched, and we can move to the S3 server. So this is about computing. So with each instance of this micro instance, we get 30 GB of free memory. To means all that it will be take almost 12 or 13 GB will be taken with the OS only, and the rest amount you can use for your website or something for trial. And for the S3, this is like a storage service. This is actually very good in terms of keeping backups or uh, keeping heavy data like the images, videos. So, and this is very cheap also in terms of normal servers, if you think of, because we don't pay for actually computing resource here. We only pay for the storage, and if we are managing of our own, we have to pay for other things also. Okay, so this is the S3 UI. So how it works is like in the normal Windows also we create a root folder or drive, then we go inside it. So here you can create a bucket. So each bucket will be unique across the globe, the name, name of the bucket. So I'll go in creating a bucket, and let's say I'll give Mindfire seminar demo. A reason you can choose where you want to store this bucket, which region on the data center region. So I'll choose this default one. Sorry, US. India is not there. You can go for Singapore one. Or they have recently launched this in Chennai also. The computing ones. Okay. So you can choose nearby whichever to our set of hosts. So this, okay, yes, reason point. So the setup logging will be there. You can set up for logging. So it will log whatever is happening in your S3 server. So we will just skip this. We'll create this bucket. Okay, so the bucket is created now. So there are different types we can assign on this bucket. Like right now it is only like a folder structure. You put things, you re-add a thing, and it will be means copied on top of it. So you cannot create a versioning capacity on this. So if you want a versioning capacity, like you want to maintain the files versions also, you can go for here. Sorry, the versioning. Now here the problem is once you enable this, you cannot disable it. You can only suspend the versioning capacity. So we will enable the versioning. Okay, this is done. Now this bucket is versioned and enabled. Actually right now I'm showing in terms of UI only how it works. So the major upload or whatever we can do through the UI, or some. But in terms of programming, there are different tool set. Like if you are working with .NET, there is .NET SDK that will be communicating with this, and it will give you the whatever APIs to connect to this service. If you are working on PHP, the PHP SDK will work, and it will tell you how to upload into a bucket. So the structure you can create here, and then you can ask the users to map there. So you can create a folder here. Then you can upload files here. Let me create file. And drag and drop. So it will upload the file to the test directory. And this S3 server doesn't actually work in terms of folders and directory that I'm using the words. This is just for means managing with the Windows system. So, but this works in a terms of the URL object. The object URL has to be unique. The folder name slash the file name. This is a unique URL. So they only understand the object URL. So this is created. Now you can make it mark as public, so everyone can actually see this image folder in HTTP. Now the version 1 file is there. Now let's say I will go back and create it as version 2 and upload the file. Oh, I didn't check the upload. Okay, this actually now overridden that one. Now we want to see the old file. So you go and check the versions here. See, let me close this one. Here you will get two version ID. So this is the ID we can track each. Maybe you are using images or any data files or whatever. So you can track those files version from with a version ID, because the URL will be the same. It won't be changing. Like if you see this URL, this is the same for this one. Till this point, this is the file name .txt. This is the S3 URL for this one. This is the bucket name, but the version ID is the only differentiating thing. So this is the means basic things on S3 server that will be actually normally used. You can upload things, you can create your structure, and then work with the SDK in terms of programming. Or if you want just a backup, then you need to link that whatever backup storage to the network drive of the S3 storage. So okay, this is done now. The second one we were using, this has been created. The date is 21st May. Now there is a security group here for this launch wizard. This is the Imagine security group that we can assign for this particular that we are creating the instance. So whatever the inbound traffic is coming, you have to give the permissions over here. So there is the RDP is by default is given at this point of time, but this is the one you need to give if you want to RDP this machine from whatever IP. If I'll give my own IP, it will take the range of IP that Mindfire is using, or the static IP it will take. So right now it is allowed to all whoever have the password and the RDP information. Then we can add some rules, custom rule that HTTP 80 we can allow the access to everyone. Then you add another rule, HTTPS allow everyone, and save them. So now it should allow everyone to access this. Let's go to the instance. Now we'll see the real imagine server that we actually got. You check this one and there is a connect button. When you connect this instance, it will give you the RDP information for this file. So you can download it and use it for your own purpose. Or these are the information. There's this and the password is here. You can get the password. Now to get the password, now you need to give that particular security password file that you have. So let me get that one. Or you can copy paste the information of that file. So this is the password. You need to decrypt it. This is your new password. You have downloaded the remote desktop file, so we can close this one. Now to use this, the IP is how much? 245. This is the RDP. I'm giving the password. Okay. So the instance was ready and we are now connecting to this instance. But yes, these instances will work very slow. But we are going only for a server one, so it's fine. If you go for a data center, by mistake once I went for a data center instance and it was damn slow. You can't do anything with the 600 MB of RAM. Instance is loading. The problem with cloud is only this: you cannot actually see the thing physically. So there are consideration like, if what if the wire is actually somebody has taken unplugged the wire, so you can't do actually on those grounds anything. There is nothing much I have to show in the instance itself. The server is ready. It is doing all the settings here. Then the instance that you have created, if you want to terminate or reboot or stop the instance, this is important. You can create 3 different instances, but you have only 750 hours of usage. So you can stop this instance right now and you can only use for 2 hours. You want to use, just start the instance and use it for 2 hours. So that is advisable, that to save some time. Okay, the server is ready here, and now whatever work we need to do, we can do here. Okay, that is mostly on the EC2 area and the S3 server. So I think that is done. If any question and answer, anything to discuss. Sorry? you want to host a website there. Then right now, if it is in like the EC2 instance, this is infrastructure. You have all full control on the server. You can now install the IIS, and if you are a .NET application, if you are hosting, install the IIS and do it. If PHP, you have to install those Tomcat server. SDK. Yes, that is in terms of programming. Like the S3 server, the file systems are not working like the one in Windows we see, and the programming changes will be like you have to upload an image or to upload any file, you need to give the key name of the file, then the path, then the bucket name with the credentials, and then there is an API method, put object method or something that you need to use, that has been provided from the SDK level. For .NET is different, for PHP it is different. So that is, yeah, that is custom, means its own set of APIs. So user can take advantage of that, and that is needed once. Yes, yes. You can install it. You can means get the EMIs are this much only. You can go for. So after that, you need to install whatever you want to. If it's a Linux server, you can. I think Cold Fusion works on Linux or not. I'm not sure. From server. Yes. Basically, the images are fine, and if the amount of storage space is problem, then S3 is the right choice. Then the communication between EC2 and S3. Space. Yeah. Yes. Yes. These are different services. The benefit of using its EC2 should not be used in terms of major storage. If you want to store some files, this is fine. But if it is a major storage like 50 GB of data that we access, maybe PDFs and videos or something, then S3 should be there. And the benefit is across region, there are few benefits. And if it is the same region, the accessibility from the EC2 server, because every time you fetch something for the website, you need to download it, and the charges are there. So for that, if it is accessing from the EC2 server, it is free. But if I'm like now downloading it directly from somewhere, it is charging the bandwidth. So EC2 S3 is very cheap in that scenario, in terms of storage, in terms of accessibility. Thank you. Where to stop this one?